And now our next speaker is Mr. Bogdanov, who is the chair, the director of the Bulgarian Investment Agency. It's my pleasure to give you the floor for a presentation.
Thank you very much, Professor Angelov. Thank you very much for inviting me here. I have prepared a few slides just to outline what is our aim at the Invest Bulgarian Agency, what we are doing as an agency, because one of the most important aspects looking to develop our industries is, of course, to attract foreign direct investments in the country, and those investments to be the ones that actually can bring value to our economy, can bring also know-how, etc. So I'll try really to be concise since we're ahead of the time. So what we are doing at the agency, first, we work with investors that are looking from the initial phase to explore Bulgarian market, but then investors that are actually deciding to establish themselves in Bulgaria. The agency actually facilitates all of that process and also coordinates the communication with the different institutions in Bulgaria, helping them actually to establish certain strategic partnerships. Yes, the situation has changed significantly, so we cannot just offer standardized services. For some investors, we are looking to tailor-made solutions, and definitely the way forward is to have a solid ecosystem in Bulgaria that can support these investments to grow. Here are some interesting facts about Bulgaria and where actually we stand in terms of economic development. As you can see here, although we are surrounded by, let's say, geopolitical instability, there are a variety of turbulences around us. The Bulgarian economy is still growing by 4% as per the end of Q2 this year. And our industry is also growing. In the end of June, it was recorded that the Bulgarian industrial production recorded the highest number of increase in the European Union with more than 17%. Something that is very favorable, not only for investors that are looking to Bulgaria, but also to the local companies, is that still Bulgaria is third biggest exporter of electricity. So in terms of resources on the market, our government is doing a variety of different initiatives to diversify, but also to secure sustainable resources in the country. And yes, talents are one of the main driving forces for the investors when they look for a new location. This is where we really look to collaborate with the local universities, but also with the private sector to develop the right talent that is required not only, again, for the local ecosystem, but also for the new investors that are looking in our country. And here I just included a short video, one of the investors that is already established in Bulgaria sharing feedback about their experience. If we have the sound, it will work out. If not, we can move forward. The presentation will be shared in any way. This is Schneider Electric. They actually have their consecutive investment in Bulgaria, being on the market for more than 20 years now. And they're building their smart green manufacturing facility now in Poland. There are 6 main priority sectors which we are targeting from the agency as a capacity to develop further FDI in the country, but also we see a huge potential for those sectors to grow also locally. We have the automotive industry, one of the fastest growing, as you may know, with about 11% of the GDP and 70,000 people directly employed. And we have mechanical engineering, mechatronics. All of those are sectors that we see more and more interest from investors to be established in Bulgaria. Of course, it's very important when we look to investors, what is actually the value added? What are the innovations that can be attracted when a new company is established in Bulgaria? And that's changed. And then it's important to have the sustainable development of the talents. So the university should be very well aligned with what we need this future talent to be developed. There are a variety of criteria for establishment, but I will skip those slides because I want to have some time to give also a word to a guest that joined us today from the ecosystem in Bulgaria, being one of the well-known world companies for producing equipment for the semiconductor industry. Here you can see some slides about companies that has been already established and very well known, not only in Bulgaria, but on the international level as well. And yes, Bulgaria is a destination where investors can find sustainable environment for development. We have a variety of multinational companies that has been already established, but those companies are actually not just bringing value to the economy, but also creating know-how here. So Bulgaria has significant contribution to the innovations that some of those companies are releasing worldwide. Here we have a short video which is summarizing basically the investment climate in Bulgaria. I will leave the video on. I think it's very relevant to invite also representatives of the industry here in Bulgaria, because semiconductor industry, of course, it's not only the chips production, there is a lot more in the industry. And we have Krasimir Petkov here with us today from Milara. It's a Bulgarian company that has been producing and delivering equipment for the semiconductor industry. So I would like also to invite Krasi and Michael here just to share some experience about the market and maybe some recommendations that they have to us. Thank you very much for your time.
Thank you, Bogdan, and I appreciate it that we have the opportunity to talk, because we should have been in this panel. We must be only a guest here, but somebody asked me to say a few words about our experience. So our company is based in the United States, but we are here in Bulgaria for about 16 years. And we're producing robots and equipment for semiconductor industry. Our customers are all over the world. We have customers in the United States, Asia, Europe. Anybody who produce anything in semiconductor industry is maybe our customer. And we're very happy to be in Bulgaria, because we're seeing the Bulgaria a land of opportunity, because this country have been very, very well known about robotics and semiconductor industry in the past. But unfortunately for the last, let's say 20 years or maybe more, this thing have been lost a little bit here. So we think we can bring something back to Bulgaria, because we did it a lot in the United States, and we think our country deserves to have part of this. Also, I would like to say that right now we're seeing huge opportunity, not just for us, but we're seeing huge opportunity for the country, because European Union and all country in Europe, which haven't been involved in semiconductor industry, have to invest heavily, because if they don't do that, they're going to get behind, because the countries in Asia are extremely fast right now in these processes. In the United States also, right now, US is trying to bring all the production back to the United States, because they are emerging technologies. There are new technologies emerge right now, and based on, let's say, 5G or power components, which is going to be strategical for the countries. Our company is very much involved in all these processes. We apologize, we don't have any presentation, because we shouldn't present anything, but I would like to say, one, to build components in Bulgaria, I don't know how easy it's going to be. They are right now something which is going to micro manufacturing, and that micro manufacturing can be very possible in Bulgaria. Also, there are new technologies like nanotechnology, or like I said, micro manufacturing. This can be the seeds to bring production of semiconductor components here in Bulgaria. And we are involved in these processes with Boston University, with Northeastern University in Boston. So we're working in nano. Right now, we're building machines for Surrey University in England. We're building machines for University in Singapore. We also have a client which is working in the most important processes for power components, and also silicon carbide substrates. So what I try to say is, we have a big opportunity because making components require a lot of processes. Processes require a lot of automation. We have that part, and I believe this is one of the steps which Bulgaria can have to have the big opportunity to get back to this semiconductor industry. I would like to present Michael Gustafson, who is the president of my company, United States, and he may say why we are in Bulgaria just with a few words.
Thank you very much, Maxi. And thank you very much for welcoming us to the event. Just put it in perspective a little bit where the semiconductor industry is today, where it's going to go, and what is required to meet current and future needs of the industry. Today, the semiconductor on the device level is about a $550 billion business. It took the industry 50 years to get to $550 billion. It will take the industry about 8 years to go from 550 billion to 1 trillion. So if you think about it, what needs to happen, the number of engineers required to support the growth is tremendous. Today, if you take all programs across the world together, how many engineers coming out of those programs are not enough to support the growth of the industry. So there's a big gap. So our vision is, right, you look at today on a square millimeter of silicon, it's about 130 million transistors. It will go the same time, next 8 to 9 years, to about 1 billion transistors per square millimeter of silicon. So that is innovation. Not just innovation from the architecture of the transistor, but throughout the value chain of the semiconductor industry. Our vision is to create a center of excellence for semiconductor automation in Bulgaria. We're working with Bogdan, we're working with a lot of participants. How can we create an ecosystem where companies in the value chain collaborate, come out with differentiated, unique, innovative products which will intersect the technology node transition of the semiconductor industry. So that's our vision. So we are encouraging everyone who is today in the semiconductor industry to work with us and say how we're going to create that ecosystem. So you're all invited to join Milara, and we are happy to work with you in the future. So thank you very much.
Thank you very much. Thank you very much for your contribution. It was very important to show and to see that you are deeply involved and, which is more important, consistently involved. So it's very important. Thank you. So now I already talked behind the scenes, but I will now change a bit the sequence of the agenda, and we'll give the floor to Professor Juin Liou, and afterwards to academic Nikolay Denkov. Professor Liou, it's your turn. He's a leading world expert in design of integrated circuit, and especially in electromagnetic interference protection. So the floor is yours for a short presentation and your main topic afterwards.
Thank you. Thank you to move my presentation earlier because I have to catch my flight to Taiwan in a few hours. I came a long way. I came from San Francisco a few days ago, and then I have to go to Taiwan, but I'm very excited to be here. I grew up in Taiwan. I was educated in the US. I worked in the US for over 30 years. And a few years ago, I came back to Asia and worked in China and Taiwan. Okay, so today, could you put up the presentation? Okay, today I would like to offer my thoughts and my suggestions about the microelectronic sector, the current status, and the future outlook. Okay. Okay, so first I will go over the background, the current status and the outlook of, yeah, I got it here. and of microelectronics. I thought about covering the reliability issue of microelectronics, but I don't think I have enough time today. So I would mainly focus on the general topic of microelectronics. Okay, so to talk about microelectronics, you need to look at the important areas of this sector. And there are 5, in my opinion, there are 5 important areas. The semiconductors, that's the materials we have to use to make chips. But there are many semiconductors we can choose. So we normally divide the different semiconductors into 5 different groups based on the time they were introduced into the market. So the first generation is silicon and germanium. This number represents the energy band gap value of the material, which is the most important parameter of the material. And the second generation, the gallium arsenic and the indium phosphide, these are what we call the compound semiconductors. Then we get into something that's more advanced, gallium nitride and silicon carbide. And the fourth generations are indium antimony and the aluminum nitride. And the fifth generation, I put a question mark because this is very, very new. It was recently invented by a group of professors at MIT, and this material is called the boron arsenide. Okay. So you can see that just on the material itself, it's a lot of choices we can have. Now, of course, we are the largest market share belongs to silicon. All right. And then the second area that's important is design. So there are many design houses, right? And then we have company working on modeling simulation. And then we have the foundries which are making manufacturing of chips. And then finally, the reliability area that's important to the semiconductor devices and circuits. Okay, now I think many of you heard about TSMC, right? Okay. And why do I talk about TSMC, by the way? Foundry is the leader in the semiconductor industry. So when you have a foundry, it could attract many related companies into the region. You heard about many successful stories in Taiwan and China, correct? And they all started with the build up the foundries in the countries. TSMC in Taiwan, and which one in China? SMIC, SMIC in Shanghai. Those are the 2 earliest and the biggest foundries that were set up in the beginning of the semiconductor industry in the 2 countries. So in 2004, I think I have to go back. There's a slide before this one, so you can see this is the continuation. Okay, so the TSMC was founded in 1987, okay, about the same time as Samsung. Okay, and then currently TSMC is the largest foundry in the world. Okay, the reason it becomes the largest is because it has 2 advantages over all other foundries in the world that make TSMC number 1. There are 2 factors. Number 1, the yield of TSMC is the best. You know what's the yield, right? Yield is the percentage of the good chips out of the total chip you manufacture, right? So if your yield is less than 90%, you probably do not make money. So you must have high yield. And TSMC has a way to have a very high yield of the chip they manufacture. Second, it has the highest production capability than any other foundries in the world. When you talk about the production capability, you have to talk about the equipment you have. Right? There are many, many different equipments. But one of the important equipment is the lithography, okay? That is used to open up the windows on the chip. And TSMC has 80, the most advanced lithography, which is the most lithography in the world. Okay, then, as I said, TSMC was founded in 1987. And how did AC got the know-how in the beginning? That's important, right? When you set up something, you must have the know-how from somewhere. And TSMC was lucky at the time. In the early 1990s, the strongest semiconductor industry was not in Taiwan. It was not in China. It was in Japan. So at the time, the US government felt the pressure from the semiconductor industry in Japan. So they decided, so this is a political reason, they decided to provide the know-how to two companies in Asia. At the time, IBM and Intel offered the know-how to two companies in Asia. The two companies, one is TSMC, the other one is Samsung. Okay, so they got a good start, right? Because they got the know-how from these very high-tech companies in the US. And then why TSMC became better than Samsung? Well, there's a reason behind it as well. Because in the early 2000s, Apple decided to make A8 chip for the cell phone, and at the end they decided to give the orders to TSMC, not Samsung. So because of that big order from Apple, TSMC became stronger than Samsung. Okay, so that's a little bit history behind the development of TSMC. And then in 2004, TSMC excelled IBM on the 0.13 micron process, and then it never looked back. Okay? And then on the other hand, IBM sold its chip business to GlobalFoundries in 2014. So as I mentioned, TSMC took off and surpassed Samsung when Apple gave its A8 chip orders to TSMC. So TSMC dominated foundry market, and in the meantime, the chip manufacturing capability in the US, including those at IBM, Intel, and TI, gradually vanishes. So now you can see on one side, it keep on growing. On the other side, in the US, it started to diminish. And TSMC announced in 2022 that the development of 3 nanometer process has gained excellent progress, and they planned to start production of 2 nanometer process in 2024. However, big companies like Apple and Intel are not embracing the sub-5 micron processes because the low return of investment. So that's why we have to be careful. If we're going to invest something like this in Bulgaria, we have to be careful because this is the example we have to look at, right? When you produce something that's so advanced, but it's so expensive, the customer may not like it because the return of investment may not be sufficient. So worrying about the China-Taiwan tension, right? Everybody knows about what's happening. And trying to regain its semiconductor footing, the US in 2020 started to build up new chip factories with the alliance of Samsung and TSMC. And recently, the US passed the Chip and Science Act to ease reliance on overseas supply chains, right? Because they have lost the production capability. Now they want to get it back. They knew it was a mistake, right? Okay, so they have this act, and the funding was about $280 billion, which is quite a bit. But in this business, that is not much because it takes $40 billion to build a foundry nowadays. Yeah, 40. So the funding may be still too small to make an impact on furthering the US chip makers, and TSMC is still likely to be the epicenter of the semiconductor war. Okay, the evolution of microelectronics can be better explained by looking at Intel processors, microprocessors. On the left, you can see this is the first Intel processor, 4004, in 1971. And on the chip, the device size was 10 micron, and you have 10,000 devices, and the speed of the processor was 10 megahertz. And in 2000, Intel introduced a Pentium microprocessor, and the size of the device was 90 nanometer, and totally you have 42 million devices on the chip, and the speed was increased to 1.5 gigahertz. So now you can see, in just about 30 years, that's the progress. So basically, the force that's driving the progress was the ability to decrease the size of the devices, right? From 10 micron to, at this time, 90 nanometer. And you know what's the state of art right now? The state of art, as I mentioned, TSMC, is about 3 micron. How to grow silicon crystal. This is the equipment. Right? So you can see a person standing here. So you have a chamber. Inside the chamber, you have this liquid silicon, which is processed pure. And then you have this rod. So the rod will have a C and then started to pull the crystal up. You cannot pull it too quickly, right? Because it's a cooling process, right? So it takes 2 to 3 days to pull a crystal. Yeah. And this is the cost for the foundry. Now, of course, the cost is increasing every year. And right now, if you want to build a 12-inch foundry, it takes about $40 million US. Okay, so I'd like to mention outlook, and then I'll give you the future direction, and that's it, right? Okay. Silicon technology can never be replaced, okay? There are some people may saying, okay, silicon is outdated, right? We need to get into new material, new technology. Don't believe that, okay? It will not be replaced because it possesses the advantage of low cost, mature process, high reliability, and excellent integration with CMOS process. Okay, no other technology, no other material can have these advantages. So therefore, it will remain as the mainstream of many years to come. Compound technologies such as gallium arsenide and gallium nitride has superb speed and power performance, but its disadvantages are the opposite of the advantages of silicon technology. So what you have here, those becomes the disadvantages of compound semiconductor. New semiconductor technologies, the 4th and 5th generation, are still in the infancy and far away from the real applications. Device size scaling has been the key driver of microelectronic progress in the past 50 years, but this has disappeared as the mass feature size is now reaching its limitation of 2 nanometer. So what do we do? The future driving forces are nanowire technology, 2D material, 3D packaging, and hybrid silicon compound process. Future prominent microelectronic applications, including artificial intelligence, organic electronic, automotive electronic, 5G, 6G wireless communications. The ever demanding for high reliability poses a challenge to the advancement of next generation technologies. So the project I'm involving with in at the universities has to do with the reliability of microelectronics. Oh, something is missing again. I don't know why. Okay, so finally, I would like to talk about my suggestions, my humble suggestions about the development of microelectronics. First of all, you have to be mindful about the market, because in microelectronic industry, it's changing very quickly. The applications are changing very quickly. So if you decided to invest on something, you have to have a crystal ball to look into the future and make sure that what you are investing will fit the future need. So that's and that's difficult. The vision, that's very difficult. So you must have a team of experts who can provide you some strategic planning on the development. And the second, as you can see from the TSMC example, if anybody is serious about developing microelectronic infrastructure, you must have a foundry. You must have a foundry. I know it's expensive, right? But you don't have to invest in an advanced foundry. You can invest into a smaller and less advanced foundry. 8-inch, 12 inches the advanced foundry, right? 8-inch foundry could be less than $10 million. And there are different foundries, so you have to make a decision. You want to do the high frequency type of foundry, like the chip for the cell phone, or you want to do the memory, like the DRAM memory, that's a different foundry, or you want to do the automotive chip, that's another type of foundry. So there are different foundries targeting different applications. Okay, and then finally, to be successful, you need to have the manpower, right? Because I cannot set up something and I don't have the quality engineers. And where do I find the manpower? Education. So it's so important to have the collaboration between university and the companies, as well as the government agencies. Silicon Valley is a role model. Why was Silicon Valley became so successful? Because it has the strong collaboration between the good universities and the many startup companies. As you know, UC Berkeley and Stanford, located in Silicon Valley. And then they have very talented professors and students. And they work with the local industry on some innovative ideas. And that's what you need here in Sofia as well. Thank you so much. That's what I have.
It was my personal and our pleasure to host you. Thank you once again. So now I would like to give the floor to academic Nikolay Denkov. I think there is no need for presenting him. He is well known. So Professor Denkov, thank you very much for being here. Please.
It is really my pleasure. Thank you. Actually, the last part of your talk was, I think, a good transition to what I should talk about. So the task as given to me was to present some short overview of the instruments that we have for funding in the next couple of years in Bulgaria in the area of research, development, and innovation. So why it is worthy to make this overview? For two reasons. One of them is that in the last 5-6 years, there is a significant development in this area, positive development. I remember just 5-6 years ago, we had only 3 main sources of funding, and it was a problem because each of them had very limited scope. While now I started to make a list, and it was difficult to keep it on one page. And second, because I have seen with my colleagues in the universities, in the Academy of Sciences, they're always very busy. So most of them know the different bits of information, but it is not that easy to have a clear picture of what is available today. So I'll try to list briefly what we have in the next several years as topics and or scope of funding, and what is the amount of funding. It's not very big from the viewpoint of the Chinese or Taiwanese or the American standards, but for Bulgaria, this is quite a progress. And I'll try to be short, and then if there are questions, I'll be ready to answer. So we have in general 2 budgets, one coming from the European funding, which is quite significant, but also in the last years, we have quite significant increase of the national funding with several different instruments. So I'll start with the European funding, where part of it is implemented in the Plan for Recovery and Resilience. I'll start with the research universities and the network of research universities, which is aiming to have such manpower in high technologies and to link the science and innovation, so on and so forth. So altogether, this will be around 120 million euros for research. I'll talk in euros to be understandable for the foreigners. And if it was the only source, it will be quite small, but then it is combined with other sources. So you have another one, which is the so-called national funding for projects that got high European scores at the European level, but there was no sufficient funding. The people that apply for these projects know that typically they have very low success rate, between 8 and 12, 13%. So that is why there is the so-called Seal of Excellence program of the European Union, where we take the evaluation that is made by international experts at European level, and we fund this by this European funding or even by national funding, as I'll explain later. So this is in several areas. One of them is for research projects, another one is for small and medium enterprises, and the third one is for the so-called widening networking type of activities. So the different universities can participate in networks with the European universities. So here we have something like 80 million euros in the Plan of Recovery and Resilience. Then we have another 26 million euros that go to the Bulgarian Academy of Sciences for development of 7 institutes, as far as I remember, in green and digital technologies. So it is to increase the capacity to make research in these areas, but also to make innovation, spin-off startups, and so on and so forth. So everywhere when I talk about the research in this program period, in the next couple of years, it is compulsory to combine the science and development and innovation. So this is for all of the sources that I mentioned. Then in the Plan for Recovery and Resilience, we have special funding for intelligent industry, or Industry 4.0, as you like to call it here. And this is quite a significant funding that is distributed in 3 funds. One of them is for growth and innovations. The second one is for green transition and circular economy. And the third one is for investment in climate neutrality and digital transformation. So altogether, this is about 1.5 billion euros. But of course, this is a combination of funding for companies and the research institutions that are related to them. And also we have another above 300 million euros that go to industrial zones. And it's mostly infrastructure, but there is a lot of debate whether these industrial zones should have their own laboratories. So part of research and development units inside the industrial zone, this was decided to be considered case by case. So this is allowed, but not compulsory. And then we have another, this around 70 million euros that go for hydrogen production, storage and delivery. These are like pilot projects for Bulgaria, trying on one side to develop our own know-how. We have some institutes that work on that, but also preparing for scaling up with other funding. This is for the plan on recovery and resilience. Then I go to the program for scientific research, innovation, digitalization, and smart transformation. So here for research and the related innovation, we have around 600 million euros. Part of them go to already established centers of excellence and centers of competence. So some of them are here in this university, others are in other universities. So this is again a way to complement the funding that go for research universities with specific tasks, to be complemented with other funding that has other specific tasks, but they can be integrated together. And this is the idea. One of them is more related to building infrastructure. The other one is more related to building human capacity, entering new research areas, and so on and so forth. And there are also some funding for regional centers, something all over Bulgaria, in the main university centers, something that remained from the previous period and was not accomplished. Then we have funding for a single digital platform for research and innovation in Bulgaria, again to represent to the world this network of universities and institutes that will be created, and also to promote open science, fair principles, and so on, something that is important to, to educate our researchers how to go into the European level, not only at the scientific research, but also in the modes of publishing, communicating with the other scientists, and so on. Then we have funding for technology transfer, national center that should have the highest know-how that will help to the centers for technology transfer in the universities, how to develop their own capacity, and some other activities related to technology transfer. And there is also again, national funding for projects that had been very highly evaluated in the European Innovation Council, European Research Council, Marie Skłodowska-Curie, and the other European programs. If they're highly rated but not funded, they can be funded from here. Now I go to the national funding. So for years we have our National Science Fund, but only for how many? 5 years. The funding increased from 7 to 18 million, so it is more than twice million euros. And here are included also the programs for excellent science, Vihrem, Peter Baron, and so on. Then we have a national roadmap for research infrastructure, something that was available only on papers until recently, but this year we spent 20 million euros for this research infrastructure. It is not only for building laboratories, but also for operating staff, and also for participation in the European projects and networks. Then we have the so-called national research programs. These are now, we have currently 14 multi-annual programs, altogether for 45 million euros, with specific goals, key performance indicators, and so on. And among them, I should mention the Insight Institute for Computer Technologies, including artificial intelligence, that is considered to be one of the stars of the Bulgarian scientific landscape. And I hope, although now they're very much, located and close to the environment, I'm sure they will open up with respect to the Bulgarian institutions in the next years. National Innovation Fund, still quite modest contribution in this area, but I hope this will also increase. And I would like to mention several projects that are in educational part, so program for education and plan for resilience and recovery and resilience in education, but very important in the context that we discussed. I'll mention the program for the national, regional, and school STEM centers. Altogether, this is for 280 million euros, and these are important because it's supposed that not only the pupils will develop their understanding, skills, and so on, but we expect also the professors from the university like yours to go to the high schools as you do with your school, but also with the other universities should do this, and prepare the next generation of scientists and attract them into the national engineering scientists, which is a big problem for Bulgaria today, to attract them. Then we have program for professional high schools, which is again something like more than 150 million euros, again something related to science, engineering, technology. We have another big program for the modernization of the programs in the universities. This is around 270 million euros. And again, combined with the infrastructural funding that I mentioned before, this will create the next generation of modern programs in the universities, combining together the human capacity and the infrastructure that is needed. So why this combination is important? Because I had a chance in the last year or so to meet different companies. They come to the Ministry of Education and Science, and we discuss together with the Minister of Economy or Minister of Innovation and Growth. And as expected, these companies that look for investment in Bulgaria, they look for the best possible candidates to work with them, and usually we need this type of funding to create the new laboratories, to create the new programs. So these investors are sure that after 1 to 3 years, they may have the people they need in their laboratories. So altogether, it is looking good. There are many administrative hurdles that the people that are on the top positions working on these projects know very well. But I'm optimistic that along with the funding, we will improve our skills, how to distribute this funding and how to use it in the best possible, efficient way. Thank you very much.
Thank you very much, Denkov, for your interesting and very informative presentation. Now I would like to invite Kamen Slavov from the Fund of Funds and to thank him that he agreed to give his place for the previous speakers. The floor is yours.
Thank you very much. Hello, my name is Kamen Slavov from the Fund of Funds. I'm here also to talk about funding. Thank you to the professor that he started to talk about this very important aspect of the development of the technology ecosystem in Bulgaria. And I hope that my presentation will be as interesting as his. So, a few words about what is the Fund of Funds. Yes. Guarantees, the banks, and so on and so forth. So we are not in the business of making presents, gifts. We are in the business of investing as a public investor. So what you see here is our current portfolio of products, just to give you a flavor of what we are doing. Basically, we support SME in general in terms of competitiveness. We support innovative SMEs as well as startups, and we give funding for municipal infrastructure, for agriculture, and so on and so forth. But today I'm here to talk about innovations, investments in innovations, and in development of the knowledge-driven economy in general. So what we do. Just a second. So what we have here is a family of venture capital funds that so far have invested in close to 200 companies. And my message to you from today is that if you have a venture, if you want to develop a project which is related to materials, to new technologies, hopefully to something connected to semiconductors as well, please come to our fund managers. There are still funds available. And we, fingers crossed, that in our portfolio we'll have the next unicorn in the country, or the next semiconductor producer, or the company that will develop a new technology in this field. So we'll be more than happy to have more robotics, more mechatronics, more materials in our portfolio. Currently we have some, and we're really looking forward for this asset class to expand in our portfolio. So, we bought more than 2,000 companies have used funding from the funds and from our partners from the private sector. So, I want investments from the state. We're very excited that we'll be looking at some new products which are very, very relevant to the teams, to the topics that we're talking now. So we have tried before, but unfortunately COVID killed the project because we have to relocate the funds. But now it seems that we'll be able to a technology transfer fund that will bridge the gap, the so-called bridging the gap between the academics and the business at last. And we hope that this fund will be sizable in terms of participation, and that it would attract a lot of private investors as well. Okay, so for the next programming period, in terms of our investment strategy, you can imagine that it sits on several pillars. One is digitalization of companies, one is innovation, and one is competitiveness in general. There will be families of instruments of our products, which will be because we're ahead of schedule. I'll be more than happy to have any questions if you have any. Yes, sure.
During the first attempt to establish technology transfer funds, it was designed more as an equity fund than the pure technology transfer funds. So it would be more talks with the industry and supporting organization this time to achieve the fund which is managed and based on a real principle for technology transfer, because it's a different business. Equity investment has nothing to technology transfer.
Sure. Look, the last time when we tried to do a technology transfer fund, we nearly succeeded. We did extensive market testing, we call it, which basically means that we talked to a lot of people. More than 70 organizations really came to us and shared their knowledge about technology transfer. To be honest, as investment professionals, we received different descriptions of what technology transfer investment is in principle from every one of them. So there is no consensus on the market what it actually means. But you have to understand that the fund of funds, the organization that I'm presenting, is again a market-driven instrument. So what we will do is that we will create an equity fund. So a fund that will finance spin-offs, that will finance startups which are looking at universities. And hopefully it will be an element of a bigger picture. I truly believe that you cannot have real technology transfer without a market-driven instrument, without promoting ideas that are looking forward to return, to a real return, to investment return. Hence, I'm not saying that it's the only right medicine the only right instrument for developing technology transfer, but it's a proper ingredient to have in the overall ecosystem in order to achieve it. This is what I believe. But when we are ready to discuss the group blueprint for the technology transfer, we'll be more than happy to have feedback from all of you and to amend our approach if needed. Thank you. Anybody else? If it's not a presentation, we can do it as a dialogue.
Yeah, you can do presentations.
As well, we're beyond that. So, okay. At the end of the presentation, you have our contacts from the funds, if you would like to see it. We'll be more than happy to talk to you offline as well. Thank you very much.
Thank you very much for your presentation. And now we are back on schedule. So our next presentation will be delivered by Professor Christophe Couteau from the Technical University of Troyes in France. We are partners with the University of Troyes within the European University of Technology. Christophe, yeah, we hear you. Please go.
Good. All right. Yeah. Perfect. Right. So, hi everyone. So, my name is Christophe Couteau. So, I'm an associate professor at the University of Technology of Troyes in France, and I'm the director of the laboratory for Light and Materials and Technologies, which is a joint research unit between the UTT, from the University, and the CRS. And today I just want to talk about what we are trying to do within our initiative of building the European University of Technology. We also would like to build a research institute called UTIN, which stands for UT+, that's the name of the University, Institute of Nanomaterials and Nanotechnologies. So before I just put briefly, I will give you more info on where we are. So this is, assuming you can see my mouse perhaps. So this is France, and so far is somewhere around here. And this is a picture of the campus. So our laboratories are these buildings, so about 1,000 people, actually 1,000 square meters of lab spaces dedicated to technologies. And of course, I was supposed to come be on site with you guys, so sorry, next time. But likewise, please come and visit us, and there is good reasons to visit us. And yeah, one more thing, so not just champagne, but also stained glass, which is also in nanotechnologies. So what we do, in a nutshell, so it's about 100 people in my institute, so we have research contracts, and average is about 2.5 million euros in research projects. We have a platform where we have our equipment. We have about, so most of our equipment is, all of our equipment is in this platform. It's a national known French platform. And we also have a graduate school that is a specific project that's been getting national funding. We build a graduate school on our topics, for photonics. And to finish, we have many projects with industry, in particular in France, there are initiatives called Lab for common laboratories, and we have one with a company called Suisse, which is a French company, and they make holograms for passports and so on. So that's interesting, partnership. And just to finish on my lab before I go into the topic, have 4 research axes that you can see here, and we observe study, control light, nanoscale, and that we have 4 research axes. So one is on interactions, light matter interactions, and nanoscale, so it's more fundamental studies. Then we have axis 2, which is based on photonics of devices, so this will be more applied, how to build actual components and devices. Then we have an axis more dedicated to fundamental studies and applied studies around biology, so biophotonics and nanosensors, and also other types of sensors actually, but a lot of also on biology. And the fourth axis is around fabrication, in particular nanofabrication, and nanosynthesis of our own particles, nano objects, and so on. And in one word, so what we're trying to do in my lab is to go from fundamental studies, for example here, spectroscopy of a single defect in diamond and room temperature, so very specific studies on how this behaves and through applications. And for example, if we have an integrated ipsometer that is now sold by a company called Phase Instruments. It is a startup company that was starting in 2018 by one of our colleagues. This is what we try to cover. So I just thought that let's start with the introduction on where I come from and what we do. And this is important because this has to be seen within a more global view. So it's perhaps a reminder, or some of you might not be aware of all this. But 2 years ago, we granted a European project to build a European University of Technology, actually, or at least to go towards initiative towards this. And so this was granted by the European Union, so it's my university, so it's the Université who is on this project. And we have 7 other partners, you can see them, the partners, and of course, Technical University of Sofia is one of them. And you can see the others, so one is based in Germany, Darmstadt University of Applied Science, and we have Riga Technical University. We also have the Technological University of Dublin, Cyprus University of Technology, Milara, we also have the Technical University of Carolina in Spain, and our colleagues from Romania, some of them talk today as well, from Technical University of Cluj-Napoca. Of course, needless to say, we don't have any British partners for obvious reasons. So this is the general trend, and with this trend, so this first initiative, so there's everything basically, so double degrees, staff mobility, changes, how we can build things together, how we can work together, and of course, one thing that we can build together is research, and that's where it comes to this initiative called UT, or UT Plus, Institute of Nanomaterials and Nanotechnologies. So what's the idea behind? The idea is to create a European Research Institute on a specific research theme. So this is one of them. There are others and instructions. And to build basically a research institute at the European level within 8 partners. Okay? So for that, there are 8 partners, there are 8 departments / institutes, depending on the various denomination in each country. By now, we can say we have around 150 people involved, permanent staff, non-permanent staff, such as PhD and postdocs and so on. Here I put a list of expertise. So it's a lot of nano, as you can see, nano-related, but it various applications, so about sensors, communication, and applications, biology, psychology, and so on and so forth. And what's the idea behind? The idea is to gather expertise and know-hows of the UT+ partners in nano-micro-related technologies, and to also gather different ways of working and approaching issues and applications in other sciences and technologies in general, in broad sense. And so in the team, so I just added this. So actually, because how should I call this? The EU team, sorry, the EUT plus mentor is think human first, so we added using nano if possible. And the idea is to create a culture where achievement promotes ethical conduct of research and research, and develop, of course, if possible, as much as possible, a strong relationship with industry. Okay. So that's the history of this ERI, this European Research Institute. So I'll just give you some dates. So in November 2020, just a few months after the actual kickoff of that UT Plus initiative, first contacts were made between institutions, and for Sofia it was the Bogdanov, for instance. And then we started in April 2021 with a workshop on manual materials. So it was fully online. It was quite successful for 2 days. Then we had some visits. We started some visits. So colleagues from Université, Kamen came from TT. Then we started to invite each other to like today, to mingle between partners. So I was invited last year by Bulgarian to talk about the same forum, and we talk about these initiatives, and then we're also trying to work out how we can have sustainability in this. So we started to apply for EU proposals, sign proposals. So the first one was a co-fund that was not successful. That was in 2021, but we tried 2022 this year, which was also not successful, but the mark is very high now, so hopefully the third one is the right one. So co-fund, the idea is to co-fund PhD students between partners. And some more visits, so I visited Dublin. So we had, in February, we had a second workshop, that was based on, it was hybrid, online, also on the site, it was in Spain. Then recently in June, we had visitors from RTU, staff member who brought in 10 students with him, so it was quite nice. And currently, what we are doing in terms of seeking research funding, we're trying to build a project, so capacity building for higher education between two of the UT Plus partners, so Kamen and UT, and with Egypt. And the idea is to build a degree, master degree in nanoscience and technologies that fit in very well with this UT institute. So what is next? So what's next is that we just applied to our university board, UT Plus board, I should say, official application for building up this ERI, so for European Research Institute. So it's on its way, so we signed by the end of the year, this year, for this team Institute on Materials. So here I listed, so the idea is to apply for 5 years with initial seed funding that will be provided, then come up with a plan, so I didn't put everything here, come up with a plan to have a sustainability for this institute, because there is a process which the institute has to live far beyond, so here it was put in for 5 years, but there is to go beyond the 5 years, of course. And here I put up this thing of work packages that we can work on the structure of the institute between us. So the first one would be coordination, management, and dissemination. How to structure the institute, so research platforms, so each of us have research platforms, so I can try to find a system to perhaps put them available or at least there so that promote changes of students or staff to go to Sofia, to go to Darmstadt, and have specific equipment that they don't have here, for instance, to develop research access, something so here. Of course, the expertise and how to link that with graduate schools, particular house, but not just house, PhD, doctoral schools that can be other partners. And then, of course, we will have to start to build joint projects with joint PhD students, staff exchanges, faculty, visiting professors, and so on and so forth. We will have a joint project close and one work package for us is to work specifically on how this institute is sustainable long term. So trying to find funding opportunities, not just trying to go for sometimes a new project and so on, but that's good. We need that, of course. But also trying to have money flowing that will allow us to have to carry on our initiative or institute beyond these 5 years for almost time. And I think that's it. So if you have any questions, I'm quite ready to answer them.
Thank you. Thank you very much, Christophe. Thank you very much. It was a pleasure. The colleagues from Niš, please, Alexandra from University of Niš, are you online? Yeah.
Okay, thank you. Thank you very much for the announcement.
I'm presenting you material on.
Sorry, I'm hearing someone else.
Now should be okay. Yeah, now should be okay.
Okay. So at first, I really need to apologize on behalf of Professor Veljkovic, who is a part of PhD commission for one candidate right now, and my colleague Marianovic, who is currently holding a workshop for high school students. So they didn't come today, but I will present our work. So my name is Sandra Veljkovic, and I will speak about the importance of higher education in electronic engineering. So at the beginning, I would like to present the highlights of our work in the previous period. So the IEEE Transaction of Education published our paper entitled The Importance of Students' Practical Work in High Schools for Higher Education in Electronic Engineering. We have been approved for 2 STEM projects financed by the IEEE, and we got 3 projects of the Center for the Promotion of Science. Also, we participated in 2 online webinars organized by the IEEE SSPS chapter and the IEEE EDS chapter. So firstly, the aim of the paper was to analyze the contribution of practical workshops attended by children in secondary schools to their success at the Faculty of Electronic Engineering. So this paper describes in detail the type of workshops, what was the topic of each one, who were the participants, and what were the results of students at the end of those courses. Also, their progress during the first year at the university or our faculty was monitored. So the paper showed that students with practical experience had much better results and had self-confidence during the courses than those who didn't have that type of experience. Here you can see the image of the project, which was the goal of workshops. And believe me that many students completed it successfully, even it looks very complicated. So here are presented some results of the paper. So the first graph represents the score of the physics laboratory exercises of the high school course participants and the freshmen who passed the exam. So it is obvious that high school students who passed the workshops had much better results. The second graph here represents the score for the electronic device lab exercises of the high school course participants and the freshmen who passed the exam. So again, we can see that participants of the workshops had better results. And it was monitored the average of the first year score for 2 academic years for the participants of the workshops and the freshmen of our faculty. So again, we can see that results of the participants of our workshops were better. Of course, when we perform our workshops, we have great cooperation with our faculty, with our ministry, with Serbian Academy of Science and Arts, many student organizations, organizations which are promoting science. And with their help, we can buy the equipment for different types of workshops. So here you can see how our site dedicated to STEM project looks like. So after every meeting, workshop, or quiz which we prepare, we write a report, we film our online workshops, because we present there how to work with some simulators or just students want to go to a workshop again, and if they didn't remember something or they just want to repeat something, it's available for them. As every year at the end, students present their practical realizations at the IEEE conference. So it was a great pleasure to have a guest from the IEEE student branch from Slovenia, from IEEE student branch from Belgium, and the IEEE regional representative, Theodorus Nikolay. So when students come to us, they go to Student Creative Center, and also from last year we have new multifunctional laboratory Lamella. So we have enough space for work, but also for practicing and entertainment. So here you can see the pictures of our multifunctional lamella, which is completely new. So in the past few months, we had a lot of workshops, and pictures on the slides you will see are presenting just a part of workshops with students. So what they learn about, they just learn about basic things of Arduino, ARM technology, Raspberry Pi, basic applications of electronics, just 3D printing. They learn about specific sensors. Here you can see the workshop at Petnica Science Center, where talented students go and work in different areas of science. So our goal is to give them enough knowledge to encourage them to start practicing what they really find fun and interesting for them, because there is much thing that they could do and be interested in. Here we had a quiz at our faculty, and after the quiz, always best students get some symbolic prizes just to motivate them to work harder. And at the end of the year, we meet again at our final event, the IEEE conference, held in the hall of our faculty. So this year, it will be the 15th conference, a jubilee for us. And participants from all workshops are preparing their projects. They will present them on the conference. They are just writing papers, and they will compete with their colleagues. So we always have a lot of new students that really feel the spirit of the ISTEC conference for the first time. But also there are students that are coming every year. And for many of the students and the faculty, this was the event after which they decided to study electrical engineering. And it is interesting that for many of young assistants at the faculty, this was the first conference in which they participated in. You can see here the pictures from the opening ceremony and from the whole of the faculty, where students come and bring their practical realizations, their projects, or they're defending their posters. And the best paper from the conference goes to student paper contest. For 14 years, we had 3 times the finalists, and 1 second and 1 third place. So we are very proud on the quality of the papers which are presented in our conference. So that would be all that I prepared. If you have any questions, please, you can ask or contact me.
Thank you for your participation. Thank you, Sandra, for your really clear presentation. Yeah. The next presenter will be Professor Neag from Department of Microelectronics, Technical University of Cluj-Napoca. The floor is yours.
Okay, thank you. So my name is Marius Neag. I am an associate professor at the Technical University of Cluj-Napoca. And I'm going to present a short material on opportunities to develop microelectronics within EUT+. As you know from Professor Couteau's presentation, the European University of Technology is a consortium of 8 universities, of which Technical University of Sofia and my university are part of. Here is an overview of my presentation, just a few points. It's 9 slides in total. So first, a couple of slides regarding opportunities for microelectronics in the general global and European context. Then we'll focus on EU-based opportunities, and at that point I'll try to explain what most people nowadays understand by microelectronics. Then we'll have more material on focused on what is happening and what we hope to do within the EUT class to develop microelectronics. So the general context, semiconductors, chips were treated as a commodity until just a few years ago. With manufacturing as the previous, well, one of the previous presenters explained, moving from the US and Europe towards Southeast Asia. For example, in the US, back in 1990, the US accounted for about 40% of global semiconductor capacity, dropping now to about 10%. 10% is also the EU's share of the global microchips market. So in fact, both blocks are producing far less than what they need, let alone export or so on. So this was brought into focus by the COVID-19 pandemic that led to a widely mediatized semiconductor crisis. More recently, trade wars and special military operations highlighted also the strategic importance to semiconductors. They are high on the list of economic sanctions in all these cases. What were the reactions? The US put together the US Chips and Science Act, a massive massive fund for boosting domestic research and manufacturing, about 50 billion, particularly focused on incentives for companies to build new chip manufacturing plants in the US, and also for advanced semiconductor R&D. EU is following suit. There are a number of initiatives. First of all, back in 2 years ago, there was a declaration on EU initiative on processor and semiconductor technologies, which resulted in an important project of common European interest, IPCEI, in microelectronics. Then the recovery and resilience facility with its component 6 focused on digital components and cloud capabilities, and also with a strong component in microelectronics. For example, in the Romanian National Recovery and Resilience Plan, there is a fund of about 500 million euros for microelectronics for this field. But more important is the European Chips Act. Again, it was mentioned in a few presentations this morning. The general, quite wide goal is to bolster Europe's competitiveness and resilience. And the highlight was this, that it will mobilize more than 43 billion euros for this sector. More specific aims you have here. What catches the eye is increase significantly the production capacity, basically double it by the end of the decade. But also very important for universities, address the skills shortage. So this was recognized as a bottleneck, and I'll have a slide later on this. I understood the European Chips Act is likely to be adopted in the first quarter next year, February maybe. So it's quite close, we hope. Now, part of it, just a few weeks, well, a short time ago, there was a workshop organized on these chips for Europe, and there were a few interesting presentations there. I think, again, this was mentioned by one of the presenters this morning. I think it was Mr. Petkov. There is one of the pillars is the Chips for Europe initiative, with the general catchphrase bringing the gap, bridging, I think, the gap from lab to fab, and the CHIPS joint undertaking. And there are 3 points here which I think worth mentioning. So the idea of building a virtual platform to reinforce Europe's IC design capacity. Also the idea of create a network of competence centers across Europe, hopefully within each EU member state. And then also enhance existing and develop new pilot lines. So this seems to be things that are going to happen fairly soon. And we should be prepared for that. Now, microelectronics it is defined quite broadly in most of these documents. So it's not only ICs or producing IC, designing and producing IC, but it's pretty much the whole value chain. So from system architecture to IC design, then chips manufacturing, packaging, system integration, and of course applications. Now, out of this, what I would call microelectronics core area are the dark blue zones. And of course, there are some overlap with, for example, chip manufacturing and sensors, very good overlap with what Professor Couteau presented. And within the EUT Plus, there are also clusters on communications, data science, and which are supporting, or they can be complementary to what I call here the core area of microelectronics. Now, talking about EUT Plus, just a few points on teaching and research existing the situation at the moment. Obviously, most EUT universities have research entities focused on microelectronics. Our colleagues in Sofia are a prime example, and all universities are have topics on microelectronics in their curriculum. Also, we started some initiative for further developing education in microelectronics within this consortium. In fact, it's a group of 3 universities: University of Sofia, Riga Technical University, and my university. We start working to establish a common master course in microelectronics. We made some progress. There is a good common ground. There are master courses already going on, which cover part of the topics and can be aligned and made into a more focused course. This would involve basically three teaching semester and 1 semester for the dissertation thesis, with students being able to spend the semester within the 3 participating universities, at least a semester, and with the final semester in their home university. That's kind of the general idea. We also talked about and start thinking about promoting and preparing for a microelectronics specialization at undergraduate level to feed students, to create the base for the master course. Now, we decided to start with the master course because it's kind of easier to organize on administrative from an administrative viewpoint. A whole specialization, a four-year program is more difficult and needs approvals and so on, but it has to be there because otherwise we won't have enough students for the master course. Now, in the research area, there's an initiative for development of a research institute in microelectronics. You saw in Professor Couteau's presentation a description of an existing or an action already started, and it was officially approved and started to develop such an institute for nanomaterials. We think it won't be optimum to try to link microelectronics to one of the existing institutes, because it's a transdisciplinary sector. But as I explained in the previous slides, it has now it's quite comprehensive, and it got a lot of attention and dedicated funds for its development. So I think it would be better to address this on research institute dedicated to microelectronics. And here are a few examples of research areas which we could do. Of course, first is IC design, RF, analog, digital, mixed signal. The 3 universities I mentioned already have strong research groups, and other universities within EUT Plus also have their research groups. So hopefully we'll get to a stage when our chip will attract the attention of well-known politicians. System architecture integration, I think it's also a good example. Multi-physics analysis and modeling, that's quite interesting area that's got more attention in the last few years, especially for power electronics. You have here an example of Professor Purcar's work in modeling electrothermal and mechanical processes within our devices, but also the packaging, testing and certification, and of course applications, right? So a lot of interesting areas, and these are only kind of the well-established areas at this stage. Of course, we can expand. Now, the bottleneck in developing microelectronics at the moment is really people, workforce, having a skilled workforce. I borrowed this nice photo from a presentation in that workshop I mentioned before. So it states very nicely, no digital without chips. Now, even 5 years ago, people would laugh at this. 10 years ago, okay, chips are, commodities. They cost next to nothing, and there are plenty of them. Now, this is recognized that cloud, despite the name, doesn't work on hot air. You need a very strong infrastructure with new chips. I would add to this, no advanced chips without designers, and not without new designers, a constant flow of new designers. But that's very difficult to achieve. In fact, it's very difficult to attract students, to convince students, electronic students, to focus to microelectronics, to start a career in microelectronics. There are several reasons. I just put here the two obvious ones. First, fierce competitions from other sectors, particularly software, with plenty of very available jobs available, but also embedded systems, applications, IoT, all these very interesting applications that attract people and have also a lower entry level. Entry level in microelectronics, in IC design is huge, right? So, 20 years ago, the usual story was somebody would spend like 3 years in a company before taking responsibility for developing a new block. Before that, it was simulations, porting, maybe all design, working with an experienced design, and so on. Now, there are good things about this. For example, this what I explained to my students is that, yes, it's difficult to get there, but then it also means that once you started on that path, there are no shortcuts for newcomers, and they have anybody who starts on analog IC design has to go through the same stages, and it will take some time to catch up, and in the meantime, you progress and so on. I would also say that experienced designers, especially RF and analog, are really, well, I would call them endangered species. Very few, and definitely not enough at this stage. So, just a final point, a few examples of how of things we do, and we know other colleagues are doing to encourage and support students. Company funding scholarships, working student programs for masters, and also this long-term R&D cooperation between universities and IC design companies. So long-term, years-long programs that will allow the universities to retain masters and PhD students and grow them as experienced researchers. So this concludes my talk. Thank you very much for your attention, and I'm looking forward for your comments and suggestions. Thank you.
Thank you very much to Professor Marius Neag from Technical University of Cluj-Napoca. Your presentation was valuable for us. You quite well represented all the aspects. Now, at the level of European University of Technologies, we have taken the challenge to develop such educational cluster within the European University of Technology Association. So I hope that it will start as quick as possible, and this quite well fits and it's quite well aligned to all the topics and all the priorities at EU level for increasing the popularity of electronics engineering and especially microelectronics to come study and go with their further career realization. So thank you very much. With this, we conclude the first session, the morning session, with all these panels and speakers. So far, we had 16 speakers. It was a tough schedule. Thank you for all of the participants. Thank you for all attenders who were here present in the hall and those that watched online, both in YouTube and in WebEx. We have a short break and we'll go on in about half an hour. Thank you very much.